Hello, in this video we're going to talk about how SpaceX landed a rocket on Earth. Let's go through some of the challenges they had to face in order to accomplish this incredible feat. In 2020, SpaceX was able to land 3 rockets back on Earth at the same time. The name of this rocket is Falcon 9, and it's the first orbital class rocket capable of reflight. Since the beginning of their project in 2016, they had a total of 103 launches, 64 total landings, and 46 reflown rockets. So let's dive in some of the physics behind these landings and how they were able to make this accomplishment. One of the first challenges they have to face is related to the rocket itself. So Falcon 9 is a 2-stage rocket with a height of 70 meters, a diameter of 3.7 meters, and a mass of almost 550 kilograms. So you can imagine how hard it is to put this thing into orbit, and imagine to land this thing back on Earth. So in order to do it, this rocket here, it's equipped with 9 engines, with a total thrust at sea level of more than 7,500 kilonewtons, and a thrust in vacuum of 8,200 kilonewtons. So here we have the trajectory from Falcon 9 rocket. So first they had the launch and the ascent. After this they have the first stage separation when the rocket leaves the Earth's atmosphere. At this point, the first stage keep moving, enters orbit, and they have the payload separation. The booster itself is the thing that returns back to Earth. For this case here, they have a flip maneuver where they put the engines facing the Earth again for the re-entry. Because it's too fast, they have to do a boost back burn in order to decrease the velocity. Then they have a grid fins deploy. I'm going to talk about these fins here a little bit further in the video. They have a re-entry burn at this point to again diminish the velocity of the rocket. They do some guidance here, controlling the trajectory in order to do the vertical landing on a ship in the ocean. So you can imagine the trajectory, just by the trajectory, the challenge they have to face here. I'm going to list some of them. One of the problems they have to face is related to the center of mass of the rocket. So Falcon 9, as I told you before, it's a 70-meter high rocket, and the center of mass is almost here in the middle. So we can see that they have a big lever arm, and this lever arm makes the rocket turns to both sides. So in order to control this movement, they had to do something. One of the solutions is a gimbal engine. So the thruster here is able to turn a little bit to the left or to the right, okay, and adjust this movement, adjust the angle of the rocket and to both sides. So this gimbal angle here is they are able to control the gimbal angle due to the gimbal thrust. Some other things that the Falcon 9 has, they have some cold gas thrusters placed here at the bottom and the top of the booster, and this cold gas thrusters also helps to do those turns and control the movement of the rocket. And also they have the grid fins. These grid fins are able to do some fine adjustments to the trajectory of the rocket. But they still have another problem. That's the rocket has a variable mass. So during launch, it's a two-stage rocket. But after this, it's just one-stage rocket. So we cut the mass of the rocket almost by half, and the center of mass changes substantially. After this, they also have to burn some fuel in order to re-enter the atmosphere. So they're burning fuel and the mass is reducing, and it changes the center of mass again. So they have to compensate it with the gas thrusters, the cold gas thrusters, and the fins. These rockets are able to burn almost 3,200 pounds of fuel and liquid oxygen per second. Another challenge they have to face is related to the high speeds of the rocket. So in order to launch the rocket, you need and leave the atmosphere, you need high speeds, and also when returning back to Earth, the rocket can achieve up to Mach 10 when returning to Earth. So these very, very high speeds, when re-entering the atmosphere, we have a huge friction on the rocket. And well, this friction, as you can see here in this image, this is the re-entry burn, causes a lot of heat. So the rocket has to face very, very high temperatures. So the big challenge here is actually related to the materials. It has to be a very, very resistant material in order to bear all these high speeds and temperatures. One thing that happens in high speeds like this, when you have an object immersed in a fluid, in our case the atmosphere, but because it's very, very hard, we have a very turbulent flow across the entire rocket, and this turbulent flow causes a lot of friction, and so they have to have materials able to resist all this turbulent flow around the rocket. For Falcon 9, they mostly use aluminum lithium alloy to resist all the situation. The last thing I want to mention is about controlling. Not only controlling the trajectory, here's an example of the Falcon Heavy launch. So it has 3 boosters, 2 of them land back on Earth and 1 of them on a ship in the ocean. So imagine all those things I told you about: the trajectory, the controlling the rocket itself, and the material. They have to replicate it to the other 2 boosters, but also have to control an infinite amount of variables during all this process. You have the launch, you have to take into account that the Earth is turning. Well, they're in space, it's a 3D controlling. Here we are seeing the trajectory in 2 dimensions, right? But it's actually 3 dimensions. And well, they have to deal with different types of fluid when they're leaving the atmosphere. Then you have vacuum, and then you re-enter atmosphere. You have all the challenges because of these non-steady situations, all right? The rocket's always moving, and well, they have to control the trajectory of the satellite after the first stage. So there's thousands of variables to control, including the velocity. So here's the velocity profile of one of the rockets, right? Starts increasing. Then they have the first stage separation. You have a burn to decrease the velocity of the rocket. Then it starts to re-enter the atmosphere, increasing the velocity. They have to do a re-entry burn again. and start decreasing the velocity until it reaches 0 and lands, right? So it's very, very hard, and that's why it's so impressive that they were able to make it in such a high precision, right? So I hope you enjoy it, and see you next time.
If you enjoyed this video, don't forget to subscribe and stay tuned.